how far does the tip of the second hand travel when moving from 9 to 1? So from 9 to 1, starting right here, going all the way to 1, how far along the outside is this going to travel? Okay, so slight mistake. It's not going to be on the outside. Like we said, it doesn't reach the outside. So it's going to go just along the inside of the outside. That didn't make any sense. It's going to go really close to the outside. Okay, all the time having a radius of 9. So even up towards this direction, this is going to be a radius of 9. So the way to approach these problems, the best way to approach these problems is that you're just finding part of the entire circle. So the entire circle would be just the circumference of a circle with radius 9. So circumference, it's going to be 2 pi r, or circumference equals pi d. Since I already have the radius, I'm going to use this one. So in our case, 2 times pi times 9. So the radius, or the circumference, is 18 pi. So that's the entire way around. But I'm just going to be looking at part of it. So I'm going to set up a proportion. I need to find this angle right here. So this is a much larger angle of 360. So the proportion that I want to set up is a proportion that looks like part of something to the entire thing, the whole. So if you've ever seen this part to whole, the part that I do know is going to be the angle, and I want to compare that to the entire thing, 360. This angle I haven't figured out yet, but I'm going to. Right now it's 360 divided by however many of these little guys there are. So 360, and I know there are 12 of these sections. I'm breaking this clock up into 12 sections. So that means each one, 12 goes into 36 evenly. It goes in there 3 times. Each one is going to be 30. So if I just look from 9 to 10, this is 30 degrees, another 30, 10 to 11, another 11 to 12, 12 to 1. So there are 1, 2, 3, 4 sections of 30. So this is 120 degrees. So I'm going to actually erase this. Whoops. So 120, or exactly 1/3 of the entire circle. Set that up to part, or the outside of this, the arc length, over the entire thing, which was 18 pi. So the way to solve this, I wanted to get rid of this 18 pi, so I take this and I move it up here, 18 pi, multiply, so the answer is going to be 120 over 360 times 18 pi. I'm going to be able to reduce this sum because 120 over 360 is just 1/3. And then looking at this, 18 divided by 3 is just 6. So this is the distance from 9 to 1. arc length from 9 to 1. Part H, ignore that. It's the same question. But anyways, for this type of problem, when you need to find the arc length, I had given you that formula a while ago, but you don't need to memorize it, just to set up this proportion part to whole. Part to whole. Again, it's going to look something like the degrees over 360, and then x over your circumference.